We're back, and as I promised, I'm going to explain to you how we can calculate the numbers of protons, electrons, and neutrons based on the periodic table. And I brought up my favorite element, sodium. It's not quite the same as table salt, that's sodium chloride. This is just sodium. It's a soft, explosive metal. Don't understand why it might be my favorite, but on this periodic table, you see the atomic number, you see the symbol, you see the name, and you see the atomic mass. And actually, I wasn't quite honest with you. I'm not going to explain this because, see, in 5th grade, for those of you that were here in 5th grade, you wrote a letter to my good friend Dr. Mendeleev to apply for entry on the periodic table. So I'm going to ask Dr. Mendeleev to come forward now. Great to meet you.
Great to see you. Great to see you.
Yes.
Surprise, surprise, I have a double identity. And today, since you already wrote me these letters a few years ago, we're going to review some stuff about our periodic table and looking at our sodium here as our example. Now, if you remember, our wonderful atomic number, which is located usually at the top, is both our number of protons, and since atoms like to be neutral in their charge, protons being a positive charge and electrons being a negative charge, these are equal. So 11 stands for the number of protons that we have, and for our case, the number of electrons as well. But we can think of it most primarily as the number of protons, because electrons, as we remember, can vary. We can have more or less. And this lovely number down here is our atomic mass. And this lets us know how many protons plus neutrons are in our atom. Now, it's a funky number. We have a decimal place. It's not an even number. We know we can't have part of a proton or part of a neutron. The reason why this is a funky number over here and we have a decimal place is because we can have different numbers of neutrons in an atom. Remember, the only thing that makes this sodium is that it has 11 protons. We can change the number of neutrons and we still have sodium as long as we have 11 protons in our atom. So this is actually an average number because there are some sodiums with more neutrons and some with less. And they take the average of them all that they find in nature and we end up with a decimal. Now we can solve that problem by rounding and we get the most common type of sodium out there. So 22.9, if you'll think back to, I believe it's fourth grade math, we can round that to 23. So here we have 23 protons and 23 neutrons equals neutrons plus protons. Sorry, excuse me. Now, we know this is an addition problem here to get this. What we can do is all we have to do is subtract protons from this, and we are left with the neutrons that are left over. Make sense? So if we subtract 11 from this number, because this is protons plus neutrons, you'll have these cancel out, which leaves us with just neutrons, and then we have 12 neutrons left over. So in our element, we have 12 neutrons, 11 protons, and 11 electrons.
I have to say, Dr. Mendeleev, your English is surprisingly good. Thank you.
I've been working on my accent.
Can you say anything in Russian?
Not a thing.
Awesome. Thank you. And next time, we'll talk more about this variable number of neutrons. But for now, protons and electrons equal the atomic number. Atomic mass minus the protons gives you the neutrons. You heard it straight from the expert, Dr. Mendeleev. Thank you.
You're welcome.